Now, continuing from our previous video where we looked at hydropalladation that actually led to the formation of our specific product A, which is actually shown to have a form of an isomer that is created alkene, and this product here we know to be called an enol ether actually led to a yield that is around 78%. So in this video here we're going to continue and build on this that actually leads us to the creation of product B in the presence of naphthyl iodide, and this actually will be done in the presence of this particular catalyst and the base with solvents, and we will have to create a mechanism that will arrive at the formation of product B. So looking at the mechanism 2 of this second step in here, we're going to create this by of course starting off with our specific type of catalyst. And before we do just that, we'll go to label some of the aromatic rings here, and this has to be done in order for we to create space, of course, for this particular exercise to be pleasant for us to actually visualize. So in here we're going to start off with palladium, and this palladium of course is 14 electrons, and we have to actually create the active form which has 16 electrons, palladium 2 plus. This is done in the presence of this particular aromatic iodide, or I'll call it a halide, of course, because you always start with halides for oxidative addition. And by this process here we've attached the iodide and the aromatic ring B to the particular complex. So the next step now is to start with our next one, which involves the product A, and our product A here is the enol ether, and this enol ether has a double bond in there, which is the pi bond that will attract to palladium. And take note here that in this case here we are going to form a complex, and take note here that due to palladium, which itself is sterically sensitive to a form of the huge Boyke groups, not only in aromatic A, which is green, but also aromatic B, which is represented as the purple, we actually can conclude that this will form a less hindered complex, and this less hindered complex will create a form of an anti, not a syn, diastereomer choice for that particular green compound. Therefore in this case we actually see that our specific next step, which involves a carbon metallation, will actually result in the aromatic ring B to actually form a sigma bond to carbon that is right there, and then our palladium will form a sigma bond with that specific complex. Therefore in this case we are going to form, as we recognize, an anti, not syn formation in there, while we have our palladium to be positioned in the same direction, which is also syn to that of aromatic B. So therefore the next step, which involves better hydride elimination, will then have to look at the hydrogens that are actually syn, not anti, to that of the palladium carbon bond. So therefore we notice that we have one hydrogen carbon that is actually syn to that of the palladium carbon bond. Therefore this hydrogen will be used, or will perform the beta hydride elimination, thereby creating a form of a double bond, which is the pi bond that is partial, and this will then lead us to the leaving of our metal complex catalyst, and this actually gives us our final product here, which is anti to each other, comparing aromatic ring A to aromatic ring B, and this is because of the carbon metallation step. This is the key and really important in this particular reaction step that leads us to the product being favorable at 93%. in terms of the yield, which is magnificent right here. And this, take note, of course, again, is anti, and this you recognize as well is the opposite of our previous reaction step in part A or part 1, where we talked about beta header elimination, which occurs twice. One is a reverse process and the other is an irreversible process. And while we also took into consideration the hydropalladation step, which was crucial for that particular video in terms of creating a alternate for which hydrogens will be used to create enol ether, which is a more stable product. So those are the key things to recognize in the comparison between that particular video and this particular video. And in this particular final step here, which is reductive elimination, in this case we have to recreate our palladium catalyst, which has 14 electrons coming from the 16 electrons palladium 2+. So therefore, using carbonate, in this case it picks up the hydrogen and this gives the electrons back to palladium, and then we have a good leaving group, which is iodide, thereby forming our cation product. And take note here that this process here is really a quick process that prevents the hydropalladation from actually happening in this particular step. So therefore, it's really crucial to decide on which base is quick and most appropriate or important to either enhance or inhibit the hydropalladation. And that is a big difference as well between the previous video and this particular video in here. So therefore, in this particular reaction cycle, there is no hydropalladation, mainly due to that particular base that is used right there. So in this particular video, the big idea conclusion is that we are able to decide on which base is appropriate that will enhance the hydropalladation step in supporting step A, and in step B we use a different base in order for we to create our final product that is anti to each other. So in product A, where we have a diastereomer created, in product B we actually create an anti that is the diastereomer that is favorable in step B. So therefore, this actually leads to a 93% yield, and this is how hydropalladation differs and actually is contrary from one step to the other. But this leads to an overall interesting sequence of reactions in organic chemistry that you should be familiar with. So that's about it for this particular video. Hope you're able to understand this and how to compare or highlight when to perform hydropalladation versus when not to perform hydropalladation. And please don't forget to hit that like, share and subscribe so as to get more videos to come and be aware of what's going on the channel. All the same, stay smart as always and believe in yourselves.